All right, Algebra 2, here are our videos for section 4.3. We're going to be solving quadratic equations by factoring, okay? And this is actually, we're going to be doing this for a few lessons. So this is like, you can think of 4.3 as part 1 of looking at factoring, and especially looking at factoring to solve quadratic equations, okay? Um, just as a reminder before we get started, because we're going to be, using some of these we're going to be using these terms here a lot in these next few sections, right? When we have a monomial, that's an expression, right? Whenever we have expressions, they're like these things right here, where there's no equal sign. It's just like a mathematical statement, like terms with some operations added to it, right? Whenever we have a monomial, that's just one term, right? One term. And so you have things like, some examples. They are, if it was just the number 2, that's a monomial. If I just had the variable x, that's a monomial. But then also if I have a coefficient and a variable as well, such as like say -4t, those are all monomials. It's one term, one thing by itself. And keeping in mind that actually, maybe another example, just to make sure we're on the same page, um, there can be lots of things in the monomial as long as it's one thing. So like another example could be like 2 times x times y. That is also a monomial. When we get to binomial, that's our two-term expressions. Ooh, that says 2 terms. Sorry. An example of that would be, let's say if I had, x plus 1. That's a binomial because there's x, 1, and then an operation in between them being done to both of them, right? I'm adding those two things. And by operation, we mean like subtraction and addition here. So another binomial would be like, let's say 2t minus 7. And then one more just so we're on the same page. And then I could have exponents attached to these as well. Another example of a binomial could be like x squared minus y. Okay, as long as there's 2 terms. And then a trinomial is, you guessed it, 3 terms. Okay, and so you can kind of make all these examples with a trinomial as well. But the one we're going to be focusing on for these next few sections is the standard form of the quadratic, right? We saw this in section 4.1. 3 terms. We have our ax squared, bx, and c. We're going to be seeing this a lot, okay? So that's the main one we're going to really focus on. We can write more examples, but we really just care about this one here. And the x, the variable, that can be anything. I could use a t squared t, y squared y. So just kind of make sure you're okay with that as we do a few of these examples, okay? So before we get into factoring, let's just kind of take a step back and remember how to multiply two of these binomials. So that's our first example. We're going to go ahead and multiply out the following expressions. All right. Oh, didn't mean to do that. Let's go ahead and start with this one. X plus 4 times x plus 7. Now, we want to go ahead and distribute because what's happening is that we're taking a binomial times a binomial. Whenever that happens, we're going to use distribution. And sometimes you call it double distribution because you're distributing the x, this one right here. We're starting with x and distributing it to both of the terms in x plus 7. And when we do that, we get x squared from this first one, x times x. And then we get x times 7, which is just 7x, plus 7x. So that's from the first one. And then when we distribute the 4, we distribute that again the same way to the x and to the plus 7. So 4 times x, that's plus 4x. And then 4 times 7 is 28. All right, so that's what we get when we multiply that out. Now we want to combine any like terms that we see. Well, we have 2 like terms right here in the middle, 7x and 4x, because they both have an x to the same power. I can't combine x squared with anything because there's no other x squared terms, and there's no other constant terms, so I can't combine the 28 with anything. So I end up with x squared. 7 plus 4 is 11x plus 28. All right, let's do the same thing with part B. We're going to go ahead and multiply that out. Here, we got to kind of be careful though, because we got to deal with an extra coefficient in the front. You can do this one of two ways. We can either distribute the 2 into x minus 1, or we could distribute the 2 into x plus 4, or we can go ahead and multiply x minus 1 and x plus 4 out first and then distribute the 2. Those are your only three options. Now notice that one of the options was not to distribute the 2 to everything, right? Because you can think of, this expression is just like a number. This expression could very well be just like 5. And this expression could very well just be 7. 2 times 5 times 7. You wouldn't do 2 times 5 and then 2 times 7 and then multiply that all together. That isn't what we would do. We would just do 2 times 5, which is 10, and then 10 times 7, which is 70, or in any other order, right? So the idea is that, pick a pair, multiply those out, and then multiply the result to whatever is left, okay? Normally, the easiest thing to do is just multiply out the binomial first, because we just did that. So let's just do the same thing, right? Let's go ahead and distribute this x first to both terms in the second one. So I'm going to keep this 2 out here, and in parentheses, I have x squared from x times 4, that's 4x. And then I'm going to go ahead and distribute the 1. 1 times x and 1 times 4. Negative 1, sorry. Right, because we have that negative attached. So negative 1 times x, that's negative x. Negative 1 times 4, that's negative 4. Okay, inside the parentheses, let's combine our like terms. We still have this 2 out in front. 2 x squared. 4 minus 1 is 3 minus 4. And now the very last step is to take the 2 and distribute it to everything inside the parentheses. So we get 2x squared plus 6x minus 8. Oh, there we go. All right, so that would be our answer there. And then that was our answer for this one. Okay, so that's what happens when we multiply these binomials together. Notice that that's exactly what we did. We took two binomials, x and x, x and x, and when we multiplied them out, we got quadratic expressions. And notice that these quadratic expressions are in standard form. Let's go ahead and look back up here. X squared, x, constant, x squared, x, constant, x squared, x, constant. They are in standard form. Okay, so that's what happens when we take two binomials with the same variable. Now, if I change this to a t, we get something different. So we don't have to worry. We're not going to worry about that right now. But if I take two binomials with the same variable, then multiply them out, then that's how I end up with a quadratic expression. All right, and so that's kind of the idea of factoring a quadratic expression. Okay, when we factor an expression, and I kind of forgot to, sorry, I keep pressing the wrong button. I kind of forgot to add it here. Let me go ahead and add it now. When we factor a quadratic expression, we're going backwards in multiplication. Now, this is true for any expression when we factor something, but right now we're just going to focus on quadratics. In chapter 5, we're going to look at bigger ones like cubic, and we're going to look at bigger exponents. But for now, we're only focusing on the quadratics. All right, and that's kind of the idea for these next few examples. We're going to factor them as a product of binomials. All right, so what does that mean? Well, like we just said here, factoring is going backwards. So we're starting with the quadratic expression, and we're trying to figure out how to get it to look something like this. Right? We're trying to figure out how to get it back to where we started with the two binomials. Okay, so I want to go from here to two binomials. We'll notice that the last term, the 28, I get that from taking 4 times 7. 4 times 7 was 28. That's where that came from. And then the middle term, the 11x, I got that from taking 4 plus 7. 4 plus 7 is 11. So that's kind of how they correlate to the two constants that were in the binomials, okay? So that's the main idea when we're factoring. If we look at part A here, sorry, in example 2, that's what we want to find out. We want to find the factors of 20 that are going to add up to, in this case, negative 9. All right, so the first thing we have to do is just start with, what are our factors of 20? Okay, now this is a little bit of review because you guys saw this in Algebra 1. So if you remember how to do this and you're just like, I don't need this explanation again, then that's totally fine. You can just kind of, if you already know the answer, you can write it down. But Algebra 1, that was 2 years ago for a lot of us. So let's go ahead and just, if you don't remember, that is totally okay. Let's watch and see how we factor. All right, so factors of 20, what are those factors? We know 1. We know 2 times 10, so 2 is in there. We know 4 times 5, so both 4 and 5. And then we have the 10 that we said earlier. And then, of course, itself, 20. So then we got to figure out pairs that are going to give us negative 9. Well, how are we going to get negative 9 from positive numbers? It's impossible, right? Unless we, subtract like 1 minus 20 or 2 minus 10 or 4 minus 5. Those gives us negative numbers. But then remember that when we are doing factors, that means that we're multiplying to get 20. One way to get a positive number from multiplying is by multiplying two positive numbers. What's another way to get a positive number? It's when you multiply two numbers together? That's when we do two negatives. So whenever this is positive, that means that the factors have same sign. Okay, so I know that these are both, whatever pairs I choose, they're both going to be negative. And since I'm going to get a negative number here, when I add them together, well, they should both be negative. So then, let me pair these up. I know that 1 and 20 gives me 20. I know 2 and 10 gives me 20. And I know 4 and 5 gives me 20. And we know that they both have to be negative in order to add up to negative 9. So now, if you're someone who's not the best at like kind of doing this stuff in your head, then you can write it out like how I'm doing. We're not all amazing at mental math. So if we need to write stuff out, let's go ahead and write stuff out, right? So whichever one of these pairs adds up to negative 9, those are the two numbers that I want. Well, in this case, negative 1 plus negative 20, that's negative 21. Negative 2 plus negative 10, that's negative 12. Negative 4 plus negative 5, that's negative 9. So then we found the pair that we would like. Okay, we have a pair, negative 4, negative 5, that, we found the pair that when they multiply together, we get our positive 20, right? Negative 4 times negative 5, that's positive 20. But then when we add them together, we get negative 9. And so that is our factor pair, and that's all we have to do. Once we found our numbers, then we know that this is going to be equal to x minus 4 and x minus 5. Okay, and maybe, you're probably thinking like, well, where did that come from? Well, remember that this is pretty much working backwards. We need to figure out what two numbers multiply to give us 20 and add up to negative 9, because that's what is happening when we multiply this out, right? So, you can always check your work by multiplying this out like we have. X times x is x squared. X times negative 5, that's negative 5x. Negative 4 times x, that's negative 4x. Negative 4 times negative 5, that's positive 20. All right, so right off the bat, we see that the positive 20 is good. We got that from up here. But now, does it satisfy the negative 9x? Negative 5 minus 4x? Yes, it does. Okay, and that's why, and maybe when you were doing factoring algebra 1 and you were kind of confused by it because maybe in algebra 1 you also made that pretty huge jump from once we got the numbers, here's the answer. That's exactly why, because of the way that this multiplies out whenever we do multiplication, right? -4 times x, -5 times x, that's where these two middle ones come from, and that's why they add together. That's why your factors have to add together. Okay, let's try another example. So t squared plus 3t minus 12. All right, same idea. We want to find the factors of 12 first. All right, we know that's 1, 2, and I'm actually might not have room, so let me start below that. We know it's 1, 2, 3, 4, 6, and 12. So we know, our pairs are 1 and 12, 2 and 6, and 3 and 4. All right, so now the only issues we have to remember, we have to keep the signs in mind, right? It has to technically multiply to -12. What's the only way to get a negative number when you're multiplying two numbers together? Well, it's when we do a positive times a negative. That's the only time we can get a negative by multiplying two numbers together. One has to be positive, one has to be negative. So that tells us something about this list right here. We know that one of them has to be negative for every single pair. But then how do we decide which one is negative? Well, that's where we use the second sign. We know that our pair is going to have to add up to a positive number. Well, how do we do that when one of them has to be negative and one of them has to be positive? Well, the only time that's going to work is if the smaller number was negative. So if this is a positive number, then the smaller number is negative. If this were a -3, then the bigger number would have to be negative, because then you get 1 minus 12, which is negative, 2 minus 6, which is negative, 3 minus 4, which is negative. But since it's positive, our smaller number is negative, because then that means we have 12 minus 1, which is positive, 6 minus 2, which is positive, and 4 minus 3, which is positive. So we're going to put the negative on all the smaller numbers, and then we're going to add until we get one that's positive 3. 12 minus 1, that's 11. 6 minus 2, that's 4. 4 minus 3, that's 1. Uh-oh, what happened here? None of the pairs that we came up with from our list of factors adds up to 3. Okay, so no, we didn't make a mistake here. The only issue is that, or the issue just means that this right here cannot be factored. So we just simply stop there. It cannot be factored. Okay, and so we call those types of quadratic expressions prime. Okay, so whenever you come across a quadratic expression that cannot be factored, we're going to call that prime. All right. We'll go ahead and do a few more examples in the next video. So meet me there.